helping to publish what MERG are actually doing now. We're looking at other things as well, but the fact that we can interact with some of the good kits that we've got as well. So it's letting the people from outside say, well, look, if we're talking about a particular item, this is what we've got. But the thing for me is the fact that even though I'm doing DIY stuff, I think obviously we're never going to really be pushing that hard, because one of the nice things with LCC or Open LCB is that we've now got commercial vendors who are making some fantastic products, and this is allowing us to interact with them. So I think that's quite a vital thing with it. Obviously, I think a lot of MERG members, or a number of MERG members, are what I would say are part of the maker community. They're happy to make things and have a go at making them. Some people do struggle sometimes with soldering, which hopefully we can help people through area groups to be able to develop that skill, to then be able to either use the MERG C-Bus kit or look at what we're doing with this protocol. Obviously, Andrew, for people who don't know, is behind Sprog DCC and Sprog LCC. And I asked him tonight, would he do as a bit of an intro or a bit of a talk about the Raspberry Pi hat? So I'll hand you over to Andrew. If we can hold questions off until Andrew's ready for people to ask it, because that helps me with editing of the videos. I don't know if people are used to using the hands up. If you want to ask a question at some point, I'll then jump in and ask Andrew to stop a second or whatever.
Yeah, I'll try and remember to pause at suitable points.
Okay.
So I haven't prepared a formal presentation, so it'd be more of a show and tell or question and answer. So what I've got set up here, which you should be able to see now, is the Raspberry Pi with the Pi LCC connected to it, a few of the extraneous bits in the surroundings. So I've got JMRI open here. You can see the Pi LCC is connected here. If I plug it in to the network, there we go. Sorry, the node it was turned to wasn't connected on. I've been messing about earlier. So you can see we've connected up to a node, much the same as you would with any other interface. So very much like the USB LCC or the USB 4 that can be used to connect to LCC. The difference with the Pi LCC is it's not a simple interface. So if we go into the configure dialog, it's a little bit slow because it uses a UART interface to Linux. We can see it reading the configuration here from the module. So rather than just being a very simple interface that passes everything through, you can actually control the LEDs that are located on the RJ45 headers and get them to respond to events, up to 4 consumer events for each LED. Now, unfortunately, sometimes the display doesn't paint correctly. Just a moment. There we go. There's something funny about JMRI occasionally where it doesn't populate all of the dialog correctly. So you can have up to 4 events, and you can have things like turning LEDs on and off on events, or showing LCC traffic. So you could use it as a monitor for packet reception and transmission, show packets that are handled only by this node, or fault indication. That doesn't actually do very much at the moment. Or just simple LED, just simple event control of the LEDs. So it gives you a little bit more functionality than just like the CAN USB 4 simply passes messages backwards and forwards. It means also that the Pi LCC has a full-blown LCC node within it, which can respond to the bootloader. So you can use it to upgrade the firmware, should that be required. I'll now try and... I'm going to should hold it a different module so I can hold it up square to the camera. It's very simple. There's very few components on it. It's mainly the CAN transceiver, an opto isolator, and a PIC. And the PIC handles the CAN protocol. And then the communication to the Raspberry Pi is done via UART. Now, that's really for historical reasons. When I first started using Raspberry Pis for Sprog products, I found the SPI and I2C drivers weren't very good. They weren't very performant. So I just used a standard UART interface because it was very easy to set up. And I've carried on using it, not had any issues so far. So it's a lot better on the Raspberry Pi 5 as well, which has the new I/O chip with better UARTs in it. So you don't need to fiddle about with the setup of the Raspberry Pi. So the other thing I was going to show, on our website, you can go to the LCC info page and you can download all of the user guides without actually having to purchase anything. So the Pi LCC user guide is there as well, which goes through the setup. There's not very much to do with the Pi LCC, to be honest, but it shows you the connectors, the LEDs. So the TX and the RX LED are the ones that can be controlled by events or can be used for just monitoring traffic. And it shows the configuration. So there isn't a great deal to go through. I mean, I think I'll probably throw it open to questions at that point.
I think the thing is, one of the reasons I just wanted to see this being brought in is because obviously to use LCC, one of the methods we use is JMRI to do all the configurations.
Yes.
So a lot of people I know don't seem to want to tie up a PC as such on their layout. So I've had a little go with the Raspberry Pi 4, and that seems to run JMRI pretty good. Now, I must admit, your images, have you done one dedicated for the LCC side yet? I know there's some bits for CBus there.
So
obviously, while Andrew's just looking for that screen, we now have got 3 methods we can actually use for connecting up to the CAN bus. So we've got the MERG CAN USB 4, which obviously you could use via a Raspberry Pi as well, or you can do that through Windows.
Yeah, I'm sharing my whole screen now. For some reason, it wouldn't let me share the window that I shared a minute ago. But here you can see the Raspberry Pi OS images. So these are built for Wayland. There's one for the Pi 4 and one for the Pi 5. They're actually hosted on Google Drive because our website can't cope with the traffic for the large downloads. And the instructions for making those should be somewhere. Oh, here. There's a doc on how those images were created. Very similar to the images we do for Sprog, just configuring the OS. It's slightly easier on the Pi 5 than the Pi 4. So obviously a lot of people use Steve Todd's image, but I don't think that will auto-detect an LCC connection. So it would still work, but you just have to go in and manually set up the connection preferences.
And I think the other thing, as I was just saying earlier, is we've now got 3 ways to get connections to the CAN bus. Obviously, doing it with Andrew's 2 commercial units give you the proper LCC connections, the RJ45s. Where with the CAN USB 4, we are then just using the normal, well, the one I've got screw terminals in. Some of the later ones may have the plug-in connector. I'm not sure, to be honest, whether that's the case with the later ones. And then the other product is your USB interface, isn't it? So they're the 3 ways we are able to connect in. On Andrew's website, he's already made a number of videos showing you the basic setups of these.
I'm just wondering whether something like the CAN Pi hat or whatever it's called might work as well. I don't know, because LCC uses a grid connect protocol, the same as CBus. So anything that can connect JMRI to CBus should be able to connect LCC as well.
Oh,
but
that's
I
helpful.
don't know that. It was somebody with more knowledge than me would need to confirm that. I don't know how that
I've got
works. Sorry?
I've got that running on a Raspberry Pi with the CAN controller with the MCP 2518 or 17. Is that the right number?
Yes, the later
Um,
one.
yeah, so that's a CAN controller on the Pi board, and it interfaces via SPI, and it uses a kernel driver to present a CAN socket interface at the operating system level. And then I had uh, OpenMRN's CAN to Ethernet bridge software running, and that was basically a CAN to Ethernet sort of gateway device for running stuff locally. So I could have a laptop just plugged into the network or whatever, and the CAN interface was, just on the house network. So it was quite a convenient thing, and that works quite well. Yeah, it was a standard CAN interface at the Raspberry Pi operating system level. So yeah, that was a good option. What speed are you running the UART at going into the operating system?
I can't remember off the top of my head. It's quite fast, but it's a very short connection, obviously.
Like 500 or something?
So the CAN bit rate is 125k bits, half duplex. So I think it's 250k bits I'm using.
Yeah,
maybe 125.
Yeah, because if you end up converting that to ASCII, then you're doubling your bytes per.
That's right. Yes. So it's double. It has to be at least double the CAN bit rate.
Yeah,
But
so
the
you try and run around 500 or something if you can. It would
yeah.
be. We had a whole lot of grief back in the day when we had a UART based UART in the link from CAN to UART to PC. So we were using an FTDI to serial, 232
Yeah.
converter, and then I think we were running at 333 or whatever it was board from the FTDI to the, I think it was a PIC. Yeah. Oh, Picarovia. I can't remember which one it was. And then, but yeah, it wasn't 100% rock solid, and I think we needed to go faster. And
Yeah.
so
I haven't seen any
330.
issues yet,
Yeah.
touch wood, but it's on the Raspberry Pi.
Yeah, just
Yeah, on the Pi 4, you have to swap the UART selections over to use the good UART, which is normally the constant. Because the second UART on the Pi 4 is normally used for Bluetooth, but it doesn't have the FIFOs and the flow control, I think. It's more limited. But on the Pi 5 with the new I/O chip, you have all the UARTs are 16550 compatible and have FIFOs. And I use flow control as well.
yeah.
So it seems to work.
Yeah. Oh well. I mean, you just have to run it at full speed and just make sure, right? Just
I
make sure
do.
there's
I
nothing.
do notice that on the Raspberry Pi, the configuration download is slower than it is over USB on Windows. I don't know whether that's the Pi OS or the UART or the speed of my flash card. I've got a fairly slow SD card in there.
Greg's put a
Interesting.
question there in the chat, Greg Palmer.
Yeah.
How's the update for the Pi LCC software handled, apt or manual?
So for the Pi LCC, it would be a firmware upgrade using the bootloader within JMRI. There's no specific software that needs APT in Linux to be upgraded. So you have JMRI, which is a download from the JMRI website, and that just connects to the Pi LCC. It's just a serial port.
One thing I did on my Pi 5 that made it a lot faster was replace the SD card with an M.2 flash drive and a hat for that, and it sped the Pi up like you wouldn't believe, including JMRI.
I have that for my Pi 5, but I tend to use the Pi 4 because it's what most customers seem to have at the moment. But yeah, you can get things a lot faster.
So obviously you'd only be updating whenever you put a release out or a new version of firmware, yes?
Yes.
Yeah, so does that answer your question, Greg?
Yeah, yeah, we're good. Thank you.
Okay.
Are you ready to talk about the other node that was on your discovery list there?
I can give you a little teaser for the S-Boost LCC.
Yeah, that's the one.
Well spotted.
Yeah.
Well, it has been a long time coming, but a few months ago, I decided to completely redesign it to add Railcom, as I may have mentioned to you, Alex. Yeah, you can see here the CDI download is a bit slower on the Pi, but it seems to have decided to go very slow today. So this is an LCC connected booster that has Railcom as well. So there's various configurations for how the track power starts up, current limits, a unique ID for the detector, and then whether you want to actually use Railcom, which feedback you want. And then there's a number of events for turning track power on and off, and status reporting for 100 over voltage over current. So that's working with Railcom channel 1 at the moment, providing data to JMRI for reporters, but it's still early days. I haven't done a lot of testing yet. So that's the node there, actually. Again, it's PIC-based because that's what I'm very familiar with. I do need to move away to something with more power eventually. There's also a proposal within the NMRA to feedback Railcom directly to the command station via the power station interface. So I'm supporting that as well. And I have a 4-channel Railcom detector in development, but I can't show that at the moment. I've got nothing to show.
Well, this is all things to look forward to then.
Yes.
Over the next few months or this year or whatever.
Yeah. So the Railcom decoding is working. The Railcom decoding is working, and another step will then be a Sprog with Railcom, which will give an ops mode programmer, a very fast programmer that can use Railcom feedback for reading CVs. But that's probably out of scope for this meeting.
No, but it's good to hear that, you know, these are the things that are being developed by people. One of the things I've been conscious of, obviously, is the importance, or what I think is important with the way LCC has been done, the fact that your boards all have the potential current draw on them. So at least you know that
Yes.
the amount of current it's likely to draw, which I think is sort of key. I know on the DIY side of it, that's something I'm going to have to look at, to be fair, to make sure people are aware, you know, there is this problem if you tend to try and put too much, not if you haven't got enough power supply, it'll start browning out, and you could end up with corruptions if you don't take that into consideration. Obviously, LCC has covered this well within their documentation, haven't they? I've been a little bit outside of their documentation.
Yeah, I mean, basically, you can connect multiple power supplies to the network. It uses diodes to isolate each power supply, and generally, the power modules are 500 milliamps in 2 directions. So on each RJ45 connector, it will supply 500 milliamps. And then somewhere downstream, there'll be another power supply also capable of supplying 500 milliamps, but isolated by diodes.
Okay. And obviously, I know we've got a number of Americans in with us, and obviously people around the world. So you're one vendor that's in the UK. I don't know. We've got RC Circuits, is it, or RR Circuits?
Yeah, there's a few vendors in the US. As far as I know, I'm the only one in Europe at the moment, in the UK and Europe. There's a few. There's one in Australia, CMOS Engineering. There's, like I say, RR Circuits, the major one. TCS now have a command station and booster that's LCC connected. One of the other American DCC vendors, I forget who it is now, has something coming out, I think. Do you know, Alex?
Yeah, that's MRC.
MRC, yes, that's right. Yeah,
And
Yeah, he's
Snowball Creek makes some
yes.
stuff too. They're in
Yeah.
Canada.
Obviously,
did
for
pre-
MERG members, Andrew does offer us a good discount. Obviously, you've got to connect up with him and supply. I believe you supply your MERG membership, is it not, Andrew?
Yes, yeah, just well, you can register on our website as a MERG member, but then send me a message via the forum to confirm.
Greg's put another question in there. Greg, do you want to jump in or?
Yeah, all I was interested in, Andrew, was do any of the nodes you supply or the terminators have transient voltage suppressors on them?
No, and I don't think the ones from our circuits do either.
Okay.
I haven't come across as anyone suggesting it's needed, but it's obviously not a bad thing. I do have all of my CAN interfaces are protected on the CAN data lines to protect the transceiver, but there's no extra protection on the voltage supply, on the power supply.
And the terminators you've got, the active terminators, are they? I mean, they're more than just a resistor.
Yes. Should I call them active? I'm not sure. It was actually it was Dick Bronson at RR Circuits who provided the circuit for me and allowed me to use it. It's just designed to fit in the RJ45. But yes, it's more than just a terminating resistor. That's also there to detect the voltages to drive the LEDs. So there is some active circuitry on there. But it's not, no, I wouldn't call it active termination.
Okay.